When we look at the section 5 examples here, we are given a parallelogram ABCD, so let's draw ourselves a parallelogram and label that. And when we label that, we go around the outside, so ABCD. And it says we have diagonals BD and AC, and those diagonals intersect, and they name that point P. So there we have our parallelogram. And we want to determine whether the figure is a rhombus, rectangle, or neither for each of the following options. So I'm going to go ahead and just copy and paste this. Now if you're working on paper here, you might want to just draw a quick version of it so that you can do that. But we'll have one for each of the examples here. Now, first one says AC is equal to BD. So AC, this whole diagonal, is congruent to this whole diagonal. So those two are congruent. When we know that the entire diagonals are congruent, we go back to our notes above, and we know that we are looking at a rectangle. So that proves by itself that we have a rectangle here for A. Second one, AB equals BC. So AB equals BC. Remember, we started with a parallelogram. So since we started with a parallelogram, adjacent sides being equal means that we're going to be able to go across as well. We look up here, our adjacent sides starting with a parallelogram is going to prove that we have a rhombus. And then finally, DP equals BP. So DP is equal to BP. What we see is that that has been bisected. Now that's true of all parallelograms, so they really didn't give us any new information here. There's nothing specific to a rhombus or rectangle that we are told. This is true of all parallelograms. So we don't know anything besides the fact that we already have a parallelogram. So we have none here. Not a rectangle or a rhombus can be proven by that information. Down below, similar type of thing. Given parallelogram PRST, determine if the following conditions determine a rectangle, rhombus, or a square. Let's draw ourselves a new parallelogram here, PRST. Label that around the outside again. And we are now told that PS is equal to RT in the first one. So PS equal to RT. So when we have equal diagonals, that always tells us that we in fact have a rectangle. So that was what we proved earlier, that we do in fact have a rectangle. So we can write rectangle here. I've copied my my parallelograms a couple spots here. Next spot we're told that PS is perpendicular to RT. So PS perpendicular to RT. And when the diagonals of a parallelogram form a right angle, they are perpendicular with each other. That proves that we have a rhombus. So right here, that would be this situation. The diagonals of a parallelogram, we started with a parallelogram. Diagonals form 90-degree angles, so that is a rhombus. And then the last one, PS equal to RT. So they are the same length. And PS is perpendicular to RT. So we have proven that it is a rectangle. With the first statement, we've proven that it's a rectangle. And with the second statement, the right angle in the middle, we have proven that it is a rhombus. So if something is a rectangle and it is a rhombus at the same time, the only shape that is a rectangle and a rhombus at the same time would be a square, because a square inherits the properties of both of those shapes. This section down here is incredibly repetitive of what's above, so you can just cross it out and move on.